All right, Algebra 2, Lesson 3.0, Day 2, Factoring Binomials and Difference of Squares. Okay. So first of all, a binomial, let's talk about what a binomial is. So 4x squared plus 6, this is an example of a binomial, right? So something with two terms. So the 4x squared is one term, and the positive 6 is the second term. So anything with two terms, we consider it a binomial, okay? Now, when we're factoring binomials, it's important to be able to differentiate between what I call regular binomials and difference of squares. Okay, a difference of squares is a special type of binomial, right? And I'll talk about that in a moment. But a regular binomial, like the example I gave you over here, the 4x squared plus 6, this would be considered a regular binomial, right? Just anything with two terms. So for example, 9x squared minus let's say 10x. This would be a regular binomial, okay? Now a difference of squares is a special type of binomial, and I'll just give you guys an example real quick. 4x squared minus 25. And I'll talk about why this is a special type of binomial. So this is a binomial, but it's a special type of binomial called a difference of squares. Right, so in a moment, we'll talk about what makes a binomial a difference of squares. Okay, and the way we factor difference of squares is a little bit different. So that's why it's important to recognize the difference between the two types of binomials. Okay. All right, so first we're going to practice factoring these binomials. All right, so we're going to factor these binomials. Right, so we're going to factor. Now all of these are going to be regular binomials. Right, so this is how you factor a regular binomial, okay? So basically binomials that are not difference of squares. And we know that factoring, the first step is always we look for a GCF. So over here, the GCF is going to be 3x, right? So then I would have 2x and then minus 1, okay? And then we cannot factor anymore, right? You notice inside parentheses, we just have x to the first power. When you have x to the first power, that means you cannot factor that anymore. So we're done, right? So we've just taken out the GCF and then that's it. Okay, so it's actually pretty easy to factor a regular binomial. Okay. Number 2, right? So we look for a GCF, right? Always look for a GCF first. So let's say, hey, I can take out an x. So if I take out an x, I would end up with 25x plus 1. And like I said before, when you have like just x inside the parentheses, you cannot factor that more. Okay. Example 3, I look for a GCF. What can I take out? Let's see, 4 and 21, nothing divides those. So it looks like I can only take out an x. So I end up with 4x minus 21. Right. Number 4 here. What can I take out? Looks like 8 and 48. I could take out an 8. That divides both evenly. And then I have 3 x's in the first term and 2 x's in the second. So we have 2 x's in common. So I could take out an 8x squared. So 8x squared times what gives me 8x to the third? Well, I need an x, right? Then minus 8x squared times what gives me 48x squared? Well, that would be 6. Okay. And then we can't factor more because we just have x, right? So the key idea you need to remember is when you only have just x inside the parentheses, you cannot factor that more. Okay. Over here, number 5, 16 and 50. What's the biggest number that divides both? Well, looks like I can only think of 2. Then I have x to the 4th and x squared. So we have 2 x's in common, so I could take out an x squared from both. So I would end up with 8x squared plus, that'd be 25 inside the parentheses, right? I'll do one more. So let's see over here, 24, 3, looks like I take out a 3. I would end up with 8x squared plus 1, okay? Now keep in mind, I'll do one more example, number 7 here. When you're factoring a binomial, you're not going to always be able to factor something out. Like for example, number 7, so we have a binomial here, but there's actually nothing to factor because nothing divides 24 and 5 evenly. And the first term has x squared and the second doesn't have an x. So number 7 is an example where there's nothing to factor, right? You cannot factor this binomial. It's pretty much the way it is, okay? So let's move on to difference of squares. So I talked about difference of squares earlier, right? So difference of squares, right? They are a special type of binomial. It's a special binomial. Okay. So how do you know when something is a difference of squares? Well, first of all, it's a binomial, so it's going to have two terms, right? So it's going to have two terms. And then it's called a difference of squares. Difference means minus, right? We're subtracting. So it has to be a minus sign between the two terms, right? And then both terms are perfect squares. So what do I mean by that? So here's an example, 9x squared minus 4. So 9x squared minus 4 is considered a difference of squares. Why? Because it meets all these three requirements. It has two terms, it's a minus in the middle, and the terms are perfect squares. So what do I mean by that? I mean, there's something squared that will give you the 9x squared, and there's something squared that will give you, right, the 4. Okay? So if you can find something that goes inside these parentheses to give you the 9x squared and the 4, that means that the 9x squared minus 4 is a difference of squares. Okay? So what squared gives you 9x squared? 3x. What squared gives you 4? 2. Okay? So we can find terms that we can square, right, to get, right, the 9x squared and the 4. Okay? So that's why the 9x squared minus 4 is a difference of squares. Okay? So if you can make the problem, right, if you can make the problem fit this pattern here, that means it's a difference of squares. Okay? I'll give you another example of a difference of squares. So let's say we have 16x squared minus 25. So is this a difference of squares? So just think, can you make this problem fit this pattern? Yeah, what squared gives you 16x squared? 4x. What squared gives you 25? 5. Right? So if you can make the problem fit this pattern, that means it's a difference of squares. Okay? And I'll show you how to factor a difference of squares in a moment. Right now, we're just making sure we know how to identify them. Do one more. How about x squared minus 100. So can we make this problem, this binomial, right, fit this pattern? Yeah, this is going to be what? This is going to be 7x. This is going to be 10. Okay, so that's how you decide if a binomial is a difference of squares. Okay, so it has to meet these three requirements right here. It has two terms, a minus sign in the middle, and both terms are perfect squares. Right? So if you can make the problem fit this pattern, that means that the two terms are perfect squares. Okay. All right, so let's talk about how do we factor a difference of squares. Okay. Now, first of all, remember when you're factoring, right? Always GCF first, so that doesn't change anything. We're always going to look for a GCF first. That's still the first step. Anytime you factor any type of problem. Okay. So number one here. So the first thing is I look for a GCF, right? So I notice, okay, there's no GCF. And then the next thing you should notice is, hey, I think this is a difference of squares, right? Whenever you guys see two terms and a minus sign in the middle, all right, there's a very good chance it's a difference of squares. It doesn't have to be, but a lot of times it is. So how do I know if this is a difference of squares? Can I make this problem, all right, can I make this binomial fit this pattern? All right, looks like I can. That would be 3x, so looks like that would be 1, okay? So if you can make this binomial fit this pattern, that means you're working with a difference of squares. And once you have this kind of format, this pattern laid out, is really simple. Your factors will be 3x plus 1 and a 3x minus 1. Basically what's inside these parentheses here, right? But one will have a plus and one will have a minus. Okay, and those will be your factors. Okay. Take a look at number 2. So I look for a GCF first. Is there a GCF? It doesn't look like there's a GCF. then I notice it's a binomial with a minus in the middle. So I want to check, is this a difference of squares? Can I make it fit this pattern? Well, it looks like that would be 3, looks like that would be 5x. So my answer, so if this is a difference of squares, so my factors would be 3 plus 5x and 3 minus 5x. Okay. Now if you want to put like, if you want to put 3 minus 5x first, that's perfectly fine. That doesn't matter. You want to do 3 minus 5x and then 3 plus 5x. That's perfectly fine. That doesn't matter. Right? Doesn't make a difference. Example 3. Look for GCF. It doesn't look like there are GCF. Right? It doesn't look like there's GCF. And then, is this a difference of squares? Let's see. Well, I can get 2x here. That'll give me that. But 21, right? There's nothing squared that will give me 21. So this is not a difference of squares. So there's no GCF, right? So there's no GCF. It's not a difference of squares. So basically, this is, this cannot be factored, right? That's the problem stays the way exactly it is. Cannot be factored. Okay. So I put something like this so you guys have to understand that, not all binomials will be factorable. Not all binomials will be difference of squares. So you guys have to recognize different types of problems and situations. Number 4 here, this one actually does have a GCF. All right, so the GCF is 3, so I have to take that out. I want to take out the GCF. Okay, that's why I'm always looking for a GCF first. I get x squared minus 16. And then I recognize inside the parentheses, hey, this looks like a GCF, sorry, not a GCF. This looks like a difference of squares, right? Because I can make it fit the pattern. That's going to be x, that's going to be 4. So my answer is going to be an x plus 4 and an x minus 4 as my factors. And then don't forget the 3 that you took out at the beginning. That has to be part of your answer. If you forget that, your answer is wrong. Okay. Example 5 here. So I look for a GCF. So it looks like I take out a 2 and also an x squared. Well, if I do that, I'm going to end up with x squared minus 49. Then I recognize, hey, that looks like a difference of squares in there. So that looks like that's going to be an x, that's going to be a 7. So my factors will be an x plus 7, x minus 7, and then don't forget your GCF at the beginning, which is 2x squared. Okay. Number 6 here, all right, I look for a GCF. Okay, so there's no GCF. And then I notice it's a binomial, but I have a plus here. If this is a plus, it cannot be a difference of squares. Okay, it cannot be a difference of squares. It has to be a minus in order to be a difference of squares. Okay, so I know it's not a difference of squares, and there's no GCF, so there's nothing else to do to this problem. Right? We cannot factor this more. Right? So it cannot be factored. It pretty much stays the way it is. Okay. So you have to remember a difference of squares must have a minus in the middle. Right? If there was a minus in the middle here, then this would be a difference of squares. Okay. Let me do the last 3. So look for a GCF. It looks like I can take out the x. So 36x minus 1, right? Now, can we factor this more? We cannot. Remember, I told you earlier, this is 36x. When you only have x, you're done factoring. You cannot factor in more, right? Because I've seen students, they'll think this is a difference of squares, right? Like, if you take 6x and you square it, it'll actually give you 36x squared, but this is only 36x. So that's why this is not a difference of squares, okay? But I've seen a lot of students factor this more, and they'll think it's a difference of squares, which is not, okay? So be careful about something like that. Over here, let's look for a GCF. I don't think there is one. No GCF. But it looks like it's a difference of squares. All right, can we get it to fit our pattern? So we get 11x squared, that'll give me the 121x squared. 2y, that'll give me 4y squared. So yep, looks like it works, and my factors will be 11x plus 2y, 11x minus 2y. Okay. And the last one, right here, no GCF, okay. And then I notice, yep, that looks like a difference of squares to me. I can make it fit this format, right? That'll be 3x and 1, So my factors are 3x plus 1, 3x minus 1.